Alright, so we're going to start now on number 11. It says plot the point in polar coordinates and find 3 additional polar representations of the point using theta being between negative 2 pi and 2 pi. So, we have 4 negative pi over 3. So first, my recommendation is that you just plot this, and then think about those 3 other points in reference to plotting it, okay? So 4 negative pi over 3. So first off, where does positive pi over 3 fall? It falls 1, 2, 3, 4 lines up. So negative pi over 3 just simply falls 4 lines down. So 1, 2, 3, 4. And we're on the 4th circle, so it falls right here. Okay, now, you should be aware of the fact that we need another r being a positive 4, and now this time we need a positive theta, because we started off with a negative theta, so this time we need a positive theta. Well, so 4, and then we go around the circle in the positive direction, and that's the way circles are meant to be read. They're meant to be read going positive r and positive theta, so that means I can just look at where this point fell. So I look at it, went around, bam, it hit right there, that's 5 pi over 3, so that means that this point is just 5 pi divided by 3. That's it, okay? So now I need a negative 4 with a positive angle, okay? So I'm going to do a negative 4, so that means I'm going to start right here. So 1, 2, 3, 4. So I start right here, right here. So negative 4. And I want to get to a positive angle. So positively around the circle would be going this direction, counterclockwise. So how many lines does it take to get to there? 1, 2, 3, 4, 5, 6, 7, 8. 8 lines. So that means that it took the measurement of an angle that is 8 lines. Well, I can go back to the beginning of the circle. I can count 8 lines over, and that's going to be the same angle. And since the circle is meant to be read that way, positive, positive, I can figure out what my angle is from the negative 4 to the point that I plotted. Alright, I can find out that same angle just by going back to the beginning and counting up 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. So 2 pi over 3. So then I have an angle of, whoops, that's not where I want that. 2 pi over 3. Alright? So now I need another negative 4, but this time I need it with a negative angle. So negative 4, negative angle. So I come out here to 4. 1, 2, 4. Oh, sorry. 1, 2, 3, 4. Now I need to go negatively, which would be clockwise around the circle. So let's count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 16. So now I'm going to go back to the original. I'm going to count 16 times around, and I'm going to see what that angle is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 4 pi over 3. So then my negative angle I need is 4 pi over 3. And bam, there you go. All right, let's try doing that again. Number 12. 5, 3 pi over 2. First I need to plot that, so I count out 5 circles. Then I go around the circle in the positive direction to get to 3 pi over 2. And that's right here. So now I need to get my 3 additional polar points. Okay, well, let's do another positive 5. And this time let's do a negative angle. So I need to go from here down to here. So how many lines would that take? 1, 2, 3, 4, 5, 6. Okay, so now let's figure out what that angle would be positively. 1, 2, 3, 4, 5, 6. It would be pi over 2. So I went negatively, so I need to say negative pi divided by 2. Whoops, that's not a p. Pi divided by 2. And there you go. Alright, so now I need a negative 5, comma, and let's do it positively first. 1, 2, 3, 4, 5. So here's negative 5. And now I just need to go from here down to here. Well, guys, that's half a circle. By now, we should know that half a circle is just pi over 2 radians. Like the angle half a circle is just pi divided by 2 radians. Okay? So now let's do our next and final point, negative 5, going in the negative direction. Okay. Well, that is, for the sake of time, I'm just going to say it's a circle plus half. I'm sorry. It is half a circle plus half a circle, so a quarter circle. Oh, a second ago I said a half a circle was pi over 2 radians. A quarter of a circle, my apologies. A quarter of a circle is pi over 2 radians. So, if I go half a circle plus another quarter, that's just going to be 3 pi divided by 2. If you really wanted to count, you could. You could just, count all the way over and then count all the way back, just like I did in number 11. Okay, but I don't want to make this video too long. Alright, number 13, negative 1, 5 pi over 6. So first I have to figure out where to plot that. Well, where does 5 pi over 6 fall if r was positive and theta was positive? It would fall right here, right? So how many lines over is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need to go to -1, and I need to count 10 lines going in the positive direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right here. Okay, so now we need to get our other 3 points. So I'm going to do -1, comma. Okay, so -1, and we need it to be a negative angle. So we need to go all the way around. So let's just count how many lines that would take. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now we're just going to figure out what 13 in the correct direction would be. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. Oh, sorry, I miscounted. There you go. So 7 pi over 6. So it'd be -7 pi divided by 6. Okay. Now we need to do where it's a positive 1. Well, positive is the way this circle is meant to be read. And I haven't done positive yet, so let's just do that. So we're at 1, and then I go around the circle to positive. So that would just be 11 pi divided by 6. And now I need to do +1 with a negative angle. So +1 with a negative angle. Well, I went 2 lines down, so I just need to look at what is the angle made if I went 2 lines up. Pi over 6. So it's a negative pi over 6. And there we go. All right, problem 14. Given a point in polar coordinates, convert it to rectangular coordinates. Okay, so you know that x is equal to r cosine theta. That's the formula. You should know that. Okay? X is equal to r cosine theta. And then for this problem, r is -3 and theta is pi divided by 2. Okay? And then if you grab your trig chart and you look up cosine of pi over 2, you will see that it is 0. And -3 times 0 is just 0. Alright, but now I need to do it for y equals. Y is equal to r sine theta. Okay, and we know that y is equal to, for this problem, -3 sine of, I thought I saw pi. Pi divided by 2. And if you look up your trig chart, you see that sine of pi over 2 is the same thing as 1. And then -3 times 1 is just -3. So then we know our point is the point 0, comma, -3. Awesome. All right. Next problem. Same question, just different numbers. So x is equal to r cosine theta once again. That is how I find the rectangular given a polar. R is 3. Cosine is 2 pi divided by 3. Okay. Cosine of 2 pi divided by 3 is equal to, sorry, I don't have a trig chart with me. Look at my trig chart. I will see that cosine of 2 pi divided by 3 is -1/2. So 3 times -1 divided by 2. So then I know that x is just going to equal -1.5. Or -3 over 2, whichever one you prefer. And then y is equal to r sine theta. And so I know that r for this problem is 3, and I know that theta is 2 pi over 3. So once again, I grab my trig chart and I look up sine of 2 pi over 3 is square roots of 3 over 2. So you have to bear with me drawing that because times square roots of 3 divided by 2. Okay, well, when you look at this, you see that there's really not a whole lot that I can do. I can multiply the whole number to the numerator. So I get y is equal to 3 square roots of 3 all divided by 2. And that's really all I can do. So then x equals this, y equals this, and I'm done. Alright, number 16. Given a point in polar coordinates, convert it to rectangular coordinates. Oh, there's 3 of these. I thought there was 2 for some reason. Okay, x is equal to, alright, I've said r cosine theta like a million times. 2 cosine of 5 pi divided by 4. So I'm going to do the same thing again. I'm going to grab my trig chart. I'm going to look up cosine of 5 pi over 4. It is negative square roots of 2 over 2, so you have to bear with me drawing this. So 2 times negative square roots of 2 over 2. Now, 2 multiplies to this, so it multiplies to the top, which then allows this 2 and this 2 to cancel, so you just get negative square roots of 2. Okay? Same idea. Y is equal to 2 sine of 5 pi divided by 4. So you grab your trig chart, and you see what sine of 5 pi over 4 is. And wouldn't you know, it's the same thing. So 2 times negative square roots of 2 divided by 2. Well, the 2's once again get to cancel, and so you get that y is just equal to negative square roots of 2. So then we get the point negative square roots of 2, comma, negative square roots of 2. And that's how you do it. All right, next problem. Given a point in rectangular coordinates, convert it to polar coordinates. Okay, so this is an x and a y, and I want an r and a theta. Well, you should remember that r is equal to the square root of x squared plus y squared. So then r is going to be equal for this problem, square root of 1 squared plus 1 squared. Well, 1 squared and 1 squared are both 1, so 1 plus 1 is just 2. So we're just going to leave that square root of 2, because anything else would be not exact. So r equals the square root of 2. So then we need to find theta. We know that tangent of theta is equal to y divided by x. Okay? And y and x are both 1, so we know it's going to be 1 over 1. Okay? 1 over 1. Which then we know it's just going to be 1. We know 1 divided by 1 is just 1. Okay, so I grab my trig chart. I look at where tangent theta equals 1. Now, this one does take a little bit of thinking. Tangent theta equals 1 at 2 places. At pi over 4 and at 5 pi over 4. So you need to stop and think, okay, which angle do I want? Do I want pi over 4 radians or 5 pi over 4 radians? Go back to your point, 1 comma 1. What quadrant does that fall in? Well, x is positive, y is positive, so it falls in quadrant 1. So that means then you want the angle that's going to make you fall in quadrant 1, which would just be pi over 4. So you get the point square root of 2 comma pi over 4. That's your answer. All right. Number 18. Given a point of rectangle, convert the point to polar coordinates. Once again, I have an x and a y. I want an r and a theta. Once again, r is equal to the square root of x squared plus y squared. So that's going to be negative 3 squared plus 0 squared. Negative 3 squared is a positive 9. 9 plus 0 is 9, so it's just 3. The square root of 9 is 3. Okay? I'm trying to rush because I'm almost out of time. And then tangent theta is equal to y over x. So in this case, that'd be 0 divided by negative 3. And 0 divided by anything is 0. So I need to look and see where tangent is equal to 0. Well, it's equal to 0 at 3 places. At 0 radians, at pi radians, and at 2 pi radians. So you have to ask yourself, where does this guy fall? Well, this guy falls on the left side of the x-axis, in between the second and third quadrant. Okay? So then I want the radians, the degree that's going to make me fall between the second and third quadrant, which would just be pi. Because 0 degrees would make you fall between, and 2 pi degrees would make you fall between the first and fourth quadrant. So you get the answer of 3 comma pi. Alright? Number 19 is the same type of problem. Okay? I'm not going to have time to finish it because I only have a minute left before my recording runs out of time, and I'm just not going to have time to get through it. Alright? So you guys do your best on it. Okay? I'm going to give you the answer. So wham! These are your answers. Okay? So take a moment, really try to go through this problem without me, see if you can get to these answers. If you can't, then maybe you need to go back and watch some of the other problems again. Okay? Last but not least are these guys right here. Okay? So once again, I encourage you to try to do this on your own because I'm not going to have time to go through each one. But honestly, guys, the way you do them is you just go to your calculator, you turn your calculator on, work with me right now, calculator. Now these are all polar, so you need to change it to polar mode. And then you just simply go to y equals and type each in and see what they look like. Okay, so this one's a limicon. I'm not sure if I spelled that right. This one's a rose because it has petals. This one's a spiral. This one's a circle. Remember, after you've graphed it, zoom 6 zoom 6, zoom 0, zoom 5. These are your friends. Okay, guys, shoot me a text or a reminder if you have any questions. Good luck. Study hard. It is going to be a hard test.